In this question, we have y equals to 1 over 1 plus x, then you have y equals to 1 minus x divided by 3. And here you're rotating this guy about x-axis. You're interested in finding the volume of rotation using either washer method or the shell method. The very first step is to visualize this. What are we dealing with? So here you have 1 over 1 plus x. This is a reciprocal function. For this function, x plus 1 cannot be equal to 0. If you set x equals to -1, you get a vertical asymptote. So x equals to -1 is a vertical asymptote. And when you plug in 0, the y value becomes 1. So the behavior of the graph is similar to this. So this is y equals to 1 over 1 plus x. And then the other guy is y equals to 1 minus x divided by 3, which is a decreasing line. When x is equal to 3, it hits x-axis. So here. If you plug in 0 for x, your y becomes 1. So roughly, let me just extend this a little bit. Roughly, this is the region that you're trying to rotate, which is the intersection between these two. So when you rotate this about x-axis, this is what you get. And your line, which is just right here, and this is your region. So assume you try to use the washer method, right? Let me erase these, we don't need these. Okay. How do we set up for the washer method here? Well, as you remember here, if you take a look at the cross section, for the cross section that you have is a washer, right? The cross section looks like a washer. So the larger radius is located on the line y equals to 1 minus x divided by 3, and the smaller radius is located on the reciprocal function that you have. Okay, perfect. So let us set it up. The volume is the definite integral of pi, the larger radius, which is 1 minus x divided by 3 to the second, minus, so here you have 1 minus x divided by 3 to the second, minus pi parentheses this guy, which is 1 over 1 plus x, and to the second, then dx. But what are the boundaries for our x, right? Our goal is to know how to set up these boundaries. X is bounded between which values? How do you find the lower bound and the upper bound? So the lower bound is very easy to detect. It is at 0. If you just take a look at the intersection, your x is at 0 here. But what is this x that the point of intersection is between these two? So the intersection between y equals to 1 over 1 plus x and y equals to 1 minus x divided by 3 is 1 over 1 plus x equals to 1 minus x divided by 3. What you can do, you can multiply both sides by 1 plus x times 3. So if you multiply the first fraction by 1 plus x times 3, you get 3 times 1 plus x divided by 1 plus x equals to 3 times 1 plus x minus x divided by 3, 1 plus x times 3. So as you can see, you can get rid of the common factors, 3 and 3, and you can simplify this. So you have 3 equals to 3x plus 3 minus x minus x squared. Bring everything to one side to simplify. So x squared, and here you have 2x minus 2x, and when you bring x3 to the other side, it is 0. So when you set it equal to 0, x is 0, x is 2, because you can factor this out. So we found the intersection at 2. So our x is bounded between 0 and 2. Perfect. So the volume can be calculated as definite integral 0 to 2. You can factor out your pi, and then you can use u sub, or you can write this in nicer format, expanded format. That totally depends on you. So this guy can be written as, let me move this a little bit here and show you how to use u sub in this case. Let's set u to be 1 minus x divided by 3. du is negative a third dx. So dx for the first integral is negative 3 du. So the very first integral can be written as volume to be pi negative 3, the integral of u squared du, and the second integral negative pi integral of 1 divided by 1 plus x to the second dx. What about this integral here? For this integral, you can basically say that, hey, my u is equal to 1 plus x, because you can simplify this integral and rewrite it this form. You can take this exponent and then write it this way. It is 1 divided by 1 plus x to the second power. For this guy, you can also use u. If you set u to be 1 plus x, for the second integral, du is equal to dx. So the first integral is negative 3 pi, a third u cubed minus pi integral of du divided by u squared. You can use a different variable if it confuses you. Instead of u, you can basically use any other variable like v. You can take v to be 1 plus x, dv is dx, and this guy can be written as, instead of u, just v. dv divided by v squared. So the volume is equal to negative 3, and you can cancel out 3 and 3, so we don't need 3 anymore. And instead of u, you can just use 1 minus x divided by 3, so minus pi 1 minus x divided by 3 to the third power, x ranges between 0 to 2, minus pi. And now this integral, the integral of dv divided by v squared, is negative 1 divided by v, so you get negative 1 divided by, what is v? v is 1 plus x, and x ranges between 0 to 2. Perfect. So the volume can be written as, so negative pi, and if you plug in 2, you get 1 minus 8 divided by 3. Let's put this in parentheses, minus if I plug in 0, I get 1 cubed or just 1, and another, so this becomes positive pi, and then if you just plug in 2, you get 1 divided by 3 minus 1 over 1 or just 1. So the volume is equal to negative pi. So 1 and negative 1, they get cancelled out. You get negative, negative, positive 8 pi divided by 3. 8 pi divided by 3. And if you combine these two, you get negative 2/3, negative 2 pi divided by 3, negative 2 pi divided by 3, or basically if you take common denominator, you get 6 pi divided by 3 or 2 pi. We can check the integral as well. And hopefully we didn't make any mistakes.